Hi, my name is Wilczek and I'm the founder of the Wolfsound blog and YouTube channel on audio programming. In the previous tutorial episode, we discussed how to set up your WebView UIs using JUCE, and we're able to display a web page in our plugin. So in this episode, we'll discuss how to communicate from the C++ backend to the WebView UI frontend so that we can create actions on the C++ side that are then interpreted on the JavaScript side. And the first thing we're going to do is we're going to go here in the plugin editor constructor and we're going to add with native integration enabled. So if you plan to use WebView UIs, it's always best to exactly set this option on. Okay, and now what we need to do is we need to be able to import the tiny little JUCE frontend framework JavaScript library to our JavaScript frontend. So for this, we're going to our index.html file. As you can see, it's right here. And we'll create a new folder here called JS. And inside this folder, we'll create index.js. And here in the index.js, we can log that this is console log, this is JavaScript frontend. And now we'll import this file in index.html. And for this, we need to simply go to index.html. And here, out of the title, we can go script type module and src js/index.html. And what's also interesting now, since the C++ backend is running as pretending to be the web server, the C++ backend also needs to read this file. Sorry, it should be index.js. Should be able to read this file and return it to the front end. So now, without recompiling our plugin, we'll be able to run this. Okay, as you can see, we have our Hello World plugin. Now, if you right-click this and we go make an inspection, then in the console, we can see that we got printed, this is JavaScript frontend. And this is the full power of WebView-based UIs because we have not recompiled our C++ plugin, right? It still simply, reads the files and returns them. And you can see the first request was for the root of our web page, and then there was a request for js/index.js, because as you can remember, in our resource provider, we are printing out the URL of the requested resource. So we see that the JavaScript got correctly imported, but now what if we want to create some communication from the C++ side to the backend? Well, this is a little bit more involved. So what we essentially need to do, if we go to libs juice and then modules and then juice GUI extra and then here native, and in JavaScript, here is this tiny little library that's can be called juce-framework-frontend. And basically this folder is something you should copy to your web page folder. And to make it easier, I've created a tiny little CMake entry that copies these files for us. Because let's think about it. When do we need to copy them? We need to copy them only when the version of the JUCE framework changes. So if the framework stays at the same version for some time, then we don't need to copy it over and over again. So in CMake, it will be a very simple command. So let me just keep this open. and go to the CMake lists file of our plugin. Okay, so this is a very simple CMake command. So we'll go file, copy, and here we need to have the path to this folder. Copy relative path. Let me paste it here. Okay, and because I'm calling this from a lower level folder, so from the plugin folder, I need to go one step up. And to be sure that I'm in the right directory, I can always go CMake current source dir. And now I'm sure that we start at the folder where this CMake lists.txt file is located. So let me replace the backward slash with the forward slashes, and let me end here with a forward slash so that I indicate I want to copy the contents of this folder, and then I specify the destination, and I want to copy this to this index.js folder. So I don't have to specify plugin, right? Because that's the folder I'm currently in. So I'll just copy CMake current source directory like this, and into the UI folder, public JS, and I want to copy it to folder called juice. So let me now regenerate this. Okay, and as you can see, the files got correctly copied here. Perfect. So we have our juice library copied, and we can go here to index.js, and we can go import all as juice from, and it's a relative import, /juice / index.js. And if everything goes right, then we are able to execute this, and we also should be able to access this object. So it's window _ juice _ backend. So let's just run our plugin, right? Because we're not, we don't have to build it again. We can just run it because we can change the files here. Okay, and as you can see, it worked. So like it really queried the right file, juice index.js, and this juices index.js queried check native interop, which is another file. So we already know it worked, but we can turn on the development console, and here you can see that we get the message from us, and we get the backend and the objects that are created by the juice library. So we're ready to go to interact with from C++ with the JavaScript frontend. Okay, so the first example we're going to look at a function that allows us to evaluate a JavaScript piece of JavaScript code in the context of the web browser, but which is invoked from C++. And what I mean by this is that we'll have a function that passes a JavaScript string to the juice library, and this JavaScript piece is executed then in the context of the browser. So for this, we'll separate the UI of our plugin into two parts. So we have a left part that will be, like regular juice C++ GUI, and the right part is going to be our WebView. Okay, so for this, in our plugin editor, we'll create here juice text button, and we're going to call it run JavaScript button. We'll call it run some JavaScript. And now here we'll add and make it visible. So add and make visible run JavaScript button. And then of course we need to get it to resized. So I want to divide our UI to half-half. So half of it will be the C++ frontend and the other half will be the WebView frontend. So I'll get the bounds. Okay. And in WebView, I'll go bounds, remove from right, and I'll simply go call get width divided by 2. So now the WebView should be on the right side of our UI. And now I can just go run JavaScript button, set bounds, bounds, remove from top. And I think 50 pixels is enough. And I'll just reduce it from each side by 5. Okay, so now I need to recompile because I changed my C++ frontend. Okay, and let us run our plugin. Okay, as you can see, we have our C++ frontend on the left, our WebView backend on the right. Let me do an inspection here. Let us have a console. And of course, if I click this button, nothing happens. So now we want to add an action that, well, when I click on this button, the some JavaScript code will be evaluated. So how do we go about this? Well, there's a nice handy function that's called evaluateJavascript. But first we need to create this handler. So run JavaScript button on click. This is simply a lambda. Okay. And here within this lambda, we need to first have our JavaScript string. So I'll have it as a raw literal. So JavaScript to run, and this will be simply console log hello from C++. Right, so as you can see, I needed to escape the double quote so that it works, that the string does not terminate prematurely. And now I can call WebView evaluate JavaScript up as JavaScript to run. And then here what we can add is a callback that will be called once the result is evaluated, right? So once this JavaScript bit completes, we can see what was the result. So it's going to be evaluation result. And now we can check if we got this result at all. So we go const auto pointer result dot get result. And here we handle the case if we got the correct result. So we can print out cout JavaScript evaluation result, and we'll output result pointer to string. Well, what if it failed? And then we can print, okay, JavaScript evaluation failed because, and then we call result get error, and we can simply query for message. Okay. So let's see, of course, I need a semicolon here because it's the end of this function. So once again, when we click our run JavaScript button, then we execute this piece of JavaScript inside the browser context. And then in C++, we handle the result of this evaluation and we check, okay, did it succeed? And then did it not succeed? So please check out the documentation about this evaluation result because it contains some system-specific bits of knowledge that you may want to look into. Not always can we see if the result failed. That's not always clear. It's based on what the browser engines deliver, so it's not dependent on JUCE. I highly encourage you to check those out. But for now, let us see how this works. Okay, and I'll run our plugin. Okay, perfect. We have it as intent. So let me look at the inspection. Here I have a console. And if I click run some JavaScript, bam, we got here hello from C++. And we get here JavaScript evaluation result, which is nothing basically, right? So like we didn't like get any error or any message, but you can see that this branch got executed. So indeed we got a result which was nothing. And we can call it a few times, and as you can see, each time hello from C++ is executed. Okay, so this was the first method to communicate from the C++ backend to the JavaScript frontend using evaluateJavascript. Okay, the next way to communicate from the C++ backend to the JavaScript frontend is to emit events in C++ that you can listen to on the JavaScript side. So for this, we'll once again have another button on the C++ GUI side that emits a JavaScript event, and on the JavaScript side, we'll listen to this event and we'll try to print some message when we intercept this. So let me open our plugin editor again, and let me create another text button. This will be called JUCE text button emit JavaScript event button, and emit JavaScript event will be its text. Okay, so here in plugin editor, once again, we need to add and make visible emit JavaScript event button in the constructor. And then in the resize, we do the same thing as before, but just with this next button. How this works. So here we can again create this handler on click, this, and we'll go here and we'll say, okay, static const juice identifier event ID, and we'll call it example event, and we'll call WebView emitEventIfBrowserVisible. So this emits the event on the JavaScript side, and we pass it event ID, and let's say I pass it the value of 42 double. So as you can see here, you can pass here any var object, right? So var objects in JUCE are kind of like JavaScript objects in that they can represent various values as kind of like a variant type. And so let's say I here pass in 42 and I want to intercept this in JavaScript. So what do I need to do in my JavaScript frontend? Well, once I have my JUCE backend loaded, I can use this to subscribe to this event. So it's window __ juice _ backend at event listener. And I need to pass here the same ID. So it's going to be example event. And here's my handler. So I'll call object from CPP backend. And this is going to, I'm going to log into console log object from CPP backend. So once again, I created a button in the C++ UI. When you click it, it emits a JavaScript event. And here in JavaScript, we add a listener to listen if this event happens. And then we log what the argument that we received from the C++ side. So now I need to build this, right? Because we changed the C++ GUI. And but if I just change the JavaScript, I wouldn't need to recompile this. Okay, let's run this. Okay, I got a new button here. Let me once again open the console, Okay, and I click emit JavaScript event, perfect, and I get 42 from the backend. It works like a charm. So these are two ways you can interact from C++ to JavaScript during runtime, but there are two additional mechanisms I want to discuss here, and these are mechanisms for injecting data or evaluating some JavaScript before the page is loaded. And let me show you what I mean by this. So here in options of our web view, we can add yet another option. Just let me maybe format this. Okay, and I can specify withUserScript. And this will be run before anything is loaded in the front end. So I'll go here. Again, it's like we need to pass in a valid Java string, and maybe I'll have it as a raw literal, so I don't have to escape anything. Right, I'll have a console log, and I'll write here C++ backend here. This is run before any other loading happens. And of course I need a semicolon at the end. Okay, so now of course I need to build this, right? Because I changed C++. And let's see what happens in our console. Okay, let me run our standalone plugin. And let me open the console. Okay, and as you can see, this got executed even before we logged this is JavaScript frontend. So C++ backend here, this is run before any other loading happens. Indeed, this was run, this JavaScript bit was run before any other loading happens. So this is very handy if you want to run some JavaScript preparation code before even your page is loaded. And now let's examine the other mechanism that is available at startup, basically passing initialization data to JavaScript. And for this, I'll have a quite funny example. So as you remember, in CMake, we can specify our company name, right? We have specified the version of our plugin with this project command here. And we also specify, we have also the name of our plugin, which by default is the project name. So we can actually extract these properties and define them as compile-time constants. And then we can inject them into JavaScript, and then we can display them. So for this, I'll create here in the index.html a little table, and this table will be then called product info. So I'll go table ID product info. Okay, and here we'll have t-head will be t-row property, and then value. And here below we'll have simply rows. Like we can add them dynamically in JavaScript, but for simplicity, I'll just have them here. Have vendor, and this is going to be empty, but I'll just name it to vendor. And then let's add another row, and this is going to be plugin name. Plugin name. And finally here, we're going to have plugin version. Plugin version. Okay, and this is our table. And as you can see, these properties are empty, right? And what we want to do here on the JavaScript side, want to simply, whilst we're loading, we want while we run this script for the first time, we can just retrieve this data. So like window _ juice, and it's called initialization, hard word, data. Okay, I hope I did not misspell it. And then we simply go document get element by ID, and we say vendor, right? So this is our vendor row, and then we go inner HTML and go data vendor, and then document get element by ID, plugin name, again inner HTML data plugin name, and the same with plugin version. Main plugin version, inner HTML data plugin version. Okay, since we have not changed anything on the C++ frontend, we should be able to load it. And as you can see, these values are undefined, right? Because we have not passed them in our C++ backend. So let us fix this quickly. So we'll go to the first we need to retrieve them in CMake, right? So in CMake we can do this very easily. So we have get target property. We want to read that property to the variable called product name. And here I need to specify of which target. So this is juice WebView plugin. And what's the property? It's juice product name. Okay, and this reads juice product name into this product name variable in CMake, right? And then I can do the same with company name. And this is going to be here simply juice company name. And finally, we can specify this as target compile time definitions. So our target again is juice WebView plugin, and this is going to be private flags. And here I'm just going to specify this. So juice product name is simply product name, and then juice company name is going to be simply company name, and juice product version simply going to be project version. Okay, so what's here? I defined, when I define our plugin, Juice internally defines some properties of our target, and then I retrieve these properties into these CMake variables, and then I pass these CMake variables as compile time constants, as strings to our project. So now these are available as simply string literals in our C++ code. So now I go to plugin editor, and after still in web browser component options, you can see we can use it for all kinds of things. So I'll pass here with initialization data, and I'll say vendor. This is what we requested on the front end. And now just pass here juice company name. Okay. And of course I made here a typo because this is a very hard word to spell. So in order not to repeat this mistake, I'll copy this twice. And here we'll have plugin name. And it's going to be juice plugin name. And here it's going to be plugin version. And here it's going to be juice product version. Okay. Is it correct with this one? Product version. Okay. Perfect. And now I need to build because I changed C++. So let me build this. Okay, I got juice plugin name, undeclared identifier. Okay, Okay, because I used here product name. Okay. So I'm supposed to have here just product name, of course. Okay, and let me run this. Perfect. And as you can see, we are now able to read this information from JavaScript, which is pretty amazing. So once again, we define these values as compile time constants, as compile time strings, and we pass them to the WebView calling withInitialisationData. And here in JavaScript, as you can see, we call window juce-initialisationData, we retrieve this data, and then we can simply read the fields of this JavaScript object, which is pretty handy for, let's say, compile time information, right? Okay, so these were all the ways that you can communicate from C++ to JavaScript frontend. So from C++ backend to JavaScript frontend. And to recap, you need to import this JUCE library in your JavaScript frontend script. And then what you can do, you can evaluate some JavaScript code from C++ in the context of the plugin window. You can emit JavaScript events from C++, and then you can also specify during initialization some JavaScript bit that will be run before your window is loaded in the browser window. And then you can specify initialization data, so basically values for the JavaScript frontend that it can readily read upon loading. So these are 4 ways that you can communicate from C++ to JavaScript. And I encourage you to debug these calls on your own to see what's the order of calling, what's the order of initialization, etc. And then once you're ready, once you're familiar with it, then proceed to the next tutorial episode where we'll discuss how to communicate from the JavaScript frontend to the C++ backend. See you in the next video. Take care.